in the deepest silences of the high desert under a canopy of stars, so dense it feels like a weight there are watchers. They are modern sentinels, custodians of the cosmic ocean, their eyes, not of flesh, but of polished glass and silicon. Here in the cold, thin air of a Chilean mountaintop, a lone astronomer monitors the slow, stately dance of the cosmos. The observatory is a temple to patience where time is measured not in heartbeats, but in the patient gathering of ancient light. For months, a particular target has been a subject of quiet fascination, a ghost, a fleeting whisper from a place beyond our own sun's embrace. Its designation is Dry Clinical C, 2028p, 4 Orion bound. But to the astronomical community, it is something more. It is a messenger, an artifact from another star system, a visitor traversing our celestial neighborhood for a brief historic moment. On this night, like 1,000 nights before, its faint signature is just one of millions of data points scrolling across a screen. It is a tiny, unremarkable smudge of light, a cosmic pilgrim drifting through the unfathomable darkness beyond the orbit of Jupiter. Then something impossible happens. A single pixel on the monitor flickers, then blooms. The automated alert system, programmed for the subtle changes of variable stars or the faint glint of a distant supernova, screams. The astronomer leans forward, her reflection a pale ghost on the screen. The numbers that accompany the image are nonsensical, erroneous. They have to be. 100-fold increase in brightness, an amplification of luminosity that defies a placid journey. In a span of hours, in the time it takes for a continent to turn from darkness into dawn, this quiet traveler has detonated. It has transformed from a faint, icy wanderer into a blazing beacon in the outer solar system. A silent, colossal explosion has taken place billions of kilometers away, and we, the inhabitants of a small blue world, are its only witnesses. What could cause such a violent, instantaneous transformation? What secrets did this interstellar comet carry from its long-lost home, secrets that have now erupted into the cold vacuum of space? To comprehend this celestial cataclysm, we must first journey back. Not just days or years, but across a gulf of time, so vast it challenges the very limits of human imagination. Our story begins in a place we will never see, a stellar nursery light years from our own solar system. Imagine a star, perhaps a little larger than our sun, or maybe smaller, cooler. It is surrounded by a swirling disk of gas and dust, a protoplanetary nebula. This is the crucible of creation, the raw material from which worlds are born. Within this churning chaos, gravity is the master sculptor. Grains of dust cling together, forming pebbles. Pebbles accumulate into rocks, rocks into planetesimals, and on the frigid outer edges of this nascent system, where the star's warmth is but a distant memory, ices of water, methane, ammonia, and carbon monoxide condense. Here our comet was born. Let us call it Nyx, after the primordial goddess of the night. For untold millennia, Nyx was an anonymous resident of this alien system, a pristine relic of its formation, a jumble of ice and rock. It orbited its parent star in a slow looping trajectory, a silent partner in a cosmic ballet with newly formed gas giants. But the universe is rarely a place of eternal stability. The delicate gravitational equilibrium of its home was shattered. Perhaps a colossal planet, a king in its own right, migrated outwards, its immense gravity acting like a cosmic slingshot. Nyx, caught in this celestial crossfire, was flung, violently accelerated beyond its star's escape velocity. It was ejected, exiled into the great star-strewn wilderness. Its journey through the interstellar medium had begun, a solitary pilgrimage through a darkness almost absolute. For millions, perhaps hundreds of millions of years, it sailed on a mountain of primordial ice, tumbling end over end through the void. The stars it passed were distant cold diamonds, their light too feeble to warm its deeply frozen core, its surface harder than granite. It was a time capsule preserving the exact chemical fingerprint of the stellar cloud from which it and its long-lost solar system had formed. Then, by sheer chance, its trajectory intersected with a gravitational oasis, the immense gentle pull of our own sun, Sol. After its eons of exile, Nix was captured, however briefly, by the gravity of a new star. It had entered our solar system. Its detection was a triumph of modern astronomy. Observatories scanning the heavens for threats and wonders flagged it. Its path was wrong. It wasn't a gentle ellipse, the signature of a native object. Its trajectory was a hyperbola, a clear indication that it was moving too fast, that it was not bound to our sun, that it was merely passing through. The discovery sent ripples of excitement through the scientific world. Like its predecessor, the enigmatic Oumuamua Nix was an emissary. Telescopes across the globe and in orbit above it turned their gaze towards this fleeting guest. Spectrometers analyzed the faint light reflecting from its surface, searching for clues to its composition, its origins. It was a slow, painstaking process. Nix was distant, faint, and moving fast. But the data began to build a picture of an object both familiar and strange. And then it erupted. The sudden, violent blossoming of light changed everything. The event, which we now call the Great Outburst of Nix, was not merely a scientific curiosity. It was a detonation of possibilities. The comet was no longer a passive subject of study. It was now an active, violent, and deeply mysterious entity. The first alerts blinking on screens from Chile to Hawaii triggered a global cascade of astronomical activity. A race against time began to capture every photon, every wavelength of information emanating from this extraordinary celestial event. The initial theory, the simplest explanation, was a process well known to us, a cryovolcanic eruption, a volcano not of fire but of ice. To understand this, we must recalibrate our sense of a volcano. Forget the molten rock and ash of earthly geology. Think instead of a cosmic soda can left in the deepest freeze of space. Imagine you have a can of carbonated water filled to the brim. You shake it vigorously, agitating the dissolved carbon dioxide gas, creating immense pressure within the aluminum walls. Then, you place it in a laboratory freezer, one that reaches temperatures hundreds of degrees below zero, colder than any place on Earth. The water inside freezes solid, but the pressurized gas remains trapped, a pocket of immense potential energy locked within the ice. The can appears stable, inert, a frozen relic. For eons, our comet Nix was precisely this cosmic soda can. Its core contained pockets of supervolatile ices like carbon monoxide. These substances have boiling points so low they would flash into gas even on the surface of Pluto. As Nix traveled through the interstellar void, its outer layers were a shield, a thick crust of water, ice, and cosmic dust, keeping the pressure contained. But as it entered our solar system, a new factor came into play: the sun. Even from billions of kilometers away, the sun's radiation is a persistent force. A faint, gentle warmth began to permeate the comet's surface. This is the equivalent of taking our frozen, pressurized soda can and placing it on a countertop in a warm room. Slowly, imperceptibly at first, the heat seeps through the outer layers. It doesn't melt the super hard water ice, not yet, but it does reach the buried pockets of hypervolatile carbon monoxide. The solid carbon monoxide begins to sublimate, turning directly into gas. The pressure inside the comet's core skyrockets. A fissure, a weak point in the ancient icy crust, begins to strain. The structure groans under the impossible tension. Then a catastrophic failure. The crust ruptures. The pressurized gas explodes outwards into the vacuum of space, a ferocious jet of ice crystals and dust moving at supersonic speeds. This is a cryovolcano, a geyser of frozen material, unleashing the energy stored for geological ages. This sudden, enormous cloud of highly reflective ice and dust expands rapidly around the comet, catching the distant sunlight. To our telescopes, this expanding shell of debris acts like a giant mirror, reflecting far more sunlight back to us than the dark, compact nucleus ever could. The comet appears to flare to surge in brightness by a factor of 100. This hypothesis is elegant. It relies on known physics. We have seen evidence of such processes on icy moons in our own solar system, like Neptune's moon Triton, with its dark plumes of nitrogen gas, or Saturn's Enceladus spewing water ice into space. Perhaps Nix was simply a larger, more volatile version of these worlds. But as the flood of new data arrived, this simple picture began to complicate. The light curve, the graph of the brightening over time, was unusual. It was too sharp, too violent for a simple gas release, and the material expanding outwards seemed clumpy. This led to a second, more destructive possibility. The comet had not simply vented, it had shattered. To grasp this concept, consider an object far more delicate than a soda can. Think of a magnificent, centuries-old vase crafted from fine porcelain. It has been sitting in a museum, in a climate-controlled room, its entire existence. It appears perfect, a flawless work of art. But on a microscopic level, it is riddled with tiny, invisible stress fractures, legacies of the firing process in the kiln centuries ago. Now imagine taking this priceless artifact and plunging it into a bath of liquid nitrogen, freezing it to its very core. Then, without warning, you place it directly into a blazing hot oven. The sudden extreme temperature difference, the thermal shock, is devastating. The outer surface expands rapidly, while the inner core remains frozen and contracted. The microscopic fractures flash through the porcelain in an instant. The vase doesn't just crack, it disintegrates. It explodes into a cloud of glittering shards, each piece a testament to the unbearable stress the object endured. Nix, our interstellar visitor, may have been just like this ancient vase. For eons it existed in the profound cold between the stars. Its body, not a single solid object, but a loose conglomeration of ice and rock, a rubble pile held together by its own weak gravity, was in a state of deep, frozen equilibrium. The journey towards our sun was its blazing hot oven. The uneven heating created immense internal stresses. Sun-facing portions warmed and expanded, while the dark side remained frigid. Ancient fissures within its structure, perhaps from past collisions in its home system, were suddenly placed under unimaginable strain. The entire celestial body may have undergone a catastrophic structural failure. It flew apart, not in a single explosive burst, but in a cascade of fragmentation. Large pieces broke away, exposing fresh, highly reflective, icy surfaces that had not seen the light of day for billions of years. These new surfaces, now exposed to the sun, began to vigorously outgas, creating their own comas, their own bright shrouds of gas and dust. Our telescopes would not see a single point of light expanding. They would see multiple bright points, a swarm of mini-comets flying in formation, each a fragment of the original body. This scenario explained the clumpiness observed in the expanding cloud. It suggested we were not witnessing an eruption from the comet, but rather the death of the comet itself, its complete and utter disintegration. Yet even this dramatic theory was challenged by some of the more exotic data streaming back from the world's most powerful observatories. The chemical signature of the expanding cloud was peculiar. there was an unexpected energy release, a thermal spike that seemed to exceed what mere fragmentation could explain. This pointed to a third, more mysterious and fundamental process, one rooted in the very nature of ice itself. We think of ice as a simple crystalline substance. The water molecules in an ice cube are arranged in a neat, orderly lattice. This is the lowest energy state for frozen water. It is stable. But in the ultra-cold, diffuse molecular clouds where comets are born, water vapor can freeze so rapidly that it doesn't have time to form this crystal structure. It becomes amorphous ice, a disordered, chaotic jumble of molecules. Imagine building a house of cards. Each card carefully placed the structure, balanced, storing potential energy in its very architecture. It is a system in a high-energy, metastable state. It looks solid, but it is deeply unstable. A single breath, a slight tremor, and the entire edifice collapses. The stored potential energy is released in a sudden flurry of motion and sound. Amorphous ice is the molecular equivalent of this house of cards. It is a high-energy form of ice, storing a significant amount of energy in its disordered structure. For millions of years, as Nix drifted in the void, its water ice remained in this volatile, amorphous state. The faint warmth of our sun was the gentle tremor that brought it all down. As the comet's temperature rose past a critical threshold around -120 degrees Celsius, a phase transition occurred. The jumbled water molecules suddenly snapped into their preferred low-energy crystalline arrangement. The house of cards collapsed. This crystallization was not a gentle process, it was exothermic. It released the stored energy as a burst of heat. This sudden internal heating flash vaporized the more volatile ices like carbon monoxide and nitrogen that were trapped within the amorphous water matrix. It was a runaway chain reaction, a solid-state explosion from within. This hypothesis was thrilling because it meant Nix was a direct probe of the physical conditions in its otherwise inaccessible birthplace. The presence of amorphous ice told us about the temperature and pressure in the nebula, where it formed light years away and eons ago. The comet was not just a messenger, it was a physicist carrying the results of an experiment conducted before the Earth even had oceans. The explosion, this brilliant outburst, was the reading of the results. A chemical message written in another solar system delivered to our doorstep, and decoded by the light of its own self-destruction. Of course, there remained a fourth, more straightforward, albeit less likely possibility, a simple collision. Space is vast, but it is not entirely empty. Could Nix, in its journey through our system, have struck a small, previously undetected asteroid, a stray piece of solar system debris? A hypervelocity impact, even with a small object, would release a tremendous amount of energy, vaporizing ice and rock and creating a brilliant flash followed by an expanding cloud of ejecta. The physics is well understood, a cosmic-scale car crash. However, the statistical odds of such a specific timely impact are incredibly small. And the light signature did not perfectly match the models of an impact event, which typically have a very fast rise time and a specific decay profile. The scientific community was a hive of debate, of frantic modeling and observation. Was it a geyser from a cryovolcano, the shattering of a fragile body, a deep chemical phase transition, or a simple, brutal impact? The truth was likely a complex combination of all these factors. A thermal shock may have caused an initial fracture which triggered a runaway crystallization event leading to a cryovolcanic outburst that tore the rest of the body apart. We were witnessing a cascade of failures, a perfect storm of cosmic forces converging on this one unfortunate, or perhaps fortunate visitor. Fortunate for us, for in its violent end, Nix revealed more about itself than a lifetime of passive observation ever could. The expanding cloud of gas and dust is now a laboratory spread across millions of kilometers of space. Spectrometers on the James Webb Space Telescope can now parse the light passing through this tenuous cloud, identifying the molecules within. They are finding water, carbon monoxide, ammonia, the expected building blocks, but they are also finding complex organic molecules, glycine, alcohols, the very stuff of life. These are the same kinds of molecules found in meteorites that have fallen to Earth. The same kinds of molecules that astrobiologists believe may have seeded our young planet with the raw materials for biology, and Nix brought them here from another star. This single explosive event has given us the clearest evidence yet that the chemical precursors to life are not unique to our solar system. They are universal, forged in the hearts of stars and the depths of molecular clouds, and ferried across the galaxy by wanderers like Nix. This raises one of the most profound questions we can ask. The theory of panspermia, the idea that life itself can be transported between worlds, between stars, has long been a fringe scientific concept. Most comets upon entering a solar system would be sterilized by radiation. But what if deep within the icy core of a body like Nix, protected by meters of water, ice, microscopic organisms, could survive the journey? Could a comet ejected from a system with life act as an interstellar seed, its explosion in our outer solar system, while destructive to the comet, is a distributive event for its contents? The dust from Nix, rich with alien organic chemistry, will now slowly rain down through our solar system over the coming centuries. It will settle on the moons of Jupiter and Saturn. It will fall into the atmospheres of the gas giants. A minuscule fraction of it will even reach Earth, indistinguishable from the normal cosmic dust that settles on our world every day. We have been seasoned ever so slightly with the stardust of another world. The event is a stark and beautiful reminder of our interconnectedness with the wider cosmos. We are not an island. We are part of a galactic ecosystem where material is exchanged between star systems over geological timescales. The atoms in our bodies were forged in long-dead stars, and now we know that the complex molecules that form our biology are likely being delivered to our shores from shores we've never seen. The story of Nix is far from over. The main nucleus is gone, shattered into a ghostly cloud, but that cloud is now the focus of intense study. We will watch as it expands, thins, and eventually dissipates, a ghostly remnant of the magnificent object it once was. The trajectories of the largest fragments are being meticulously calculated, and already mission planners are dreaming. Could we send a probe, a fast, nimble spacecraft, a successor to missions like Stardust and Rosetta? It would be a chase, a race to intercept a piece of the wreckage before it escapes back into the interstellar void forever. Such a mission would be a journey to another star system without ever leaving our own. To touch a piece of Nix would be to touch the fabric of a different creation. To analyze it in our laboratories would be to read the pages of a book whose library is light years away. What would we find? Would its isotopic ratios be different from our own, a definitive signature of its alien origin? Would we find even more complex organic compounds, perhaps in our wildest dreams evidence of something more? The explosion of Comet Nix is a singular moment in human history. A moment when the true nature of the cosmos was laid bare. It is not a static clockwork machine. It is a living, breathing, violent and creative place. A universe where things happen. Where visitors from afar can arrive unannounced and depart in a blaze of unexpected glory, leaving behind a trail of questions and a universe of possibilities. Back in the high desert, the dome of the great observatory rotates. Its gaze is still fixed on the fading ghost of what was. The data continues to flow. The story continues to unfold. The comet is gone, but its legacy is only just beginning. It has reminded us that for all we have learned about the cosmos, we have barely begun to read the first page, and that the most profound discoveries are often waiting for us in the dark, in the cold, in the silent places heralded by a sudden, inexplicable and beautiful burst of light. A fleeting message from the great starry wilderness, reminding us that we are not alone in the materials we are made of, and that the universe is far stranger and more wonderful than we have ever dared to imagine, undefined,